So let's talk about baud rates. There is in PIC 24 sorry for my writing. Come on, having a hard time writing. In PIC 24, there's a baud rate generator. Baud rate generator. So baud rate can be calculated using this formula. Is equal to FCY. This is the our clock speed. Like for our microcontroller is 16 megahertz, right? And 16 UX BRG. Okay, plus 1. So this is the formula, and so from there, so if you know your microcontroller frequency, and then if you know, like, based on the URBG value, you select, again, you select this based on what baud rate you want, so you can calculate the baud rate. So if you know this, and then if you pick value for this one, then you can calculate the baud rate. The opposite is true. So let's say you want certain baud rate, and you want to figure out what should be the register value for this, then you can solve for that. So in that case, I'm just gonna remove these. In that case, you can just solve for that, meaning UX BAR. Oops, I'm gonna use black. Sorry. UXBRG is going to be, if you just solve for UXBRG here, then it's going to be equal to FCY over, obviously, 16 times baud rate minus 1, right? So you can easily calculate that. So let's do one example here. Okay, so let's do one example here. Let's say FCY equals 4 megahertz, and desired baud rate. Okay, and desired baud rate is 9600. So what should be your, then the question is, what should be your UX BRG value that you need to set up? Okay, so that's the question. Well, the answer is we can easily just plug in the, so we have these two formula, right? So I'm just gonna, they are important, so I'm just gonna do this, and same thing for this one. Okay, and highlight these. Again, these are important formulas that we are gonna use when we try to set the UART communication. Okay, so using the second formula there, so we can find that UX BRG is equal to, again, FCY over 16 times baud rate. right? So oops, -1, that's the formula says. And so if we do that, 4 times 10 to the 6, because FCY given as 4 megahertz, and then 16 times baud rate, that desired baud rate is 9600 minus 1. So from here we get 25.04166. Of course, this is our registered UXBRG is 16-bit. Registered, so we cannot put like a decimal point. So it has to be integer, whole number. So that's why we kind of skip this part. So the result, we ignore that part. So the result is 25. Again, it has to be integer. Okay. So that's how you calculate. Okay, so based on your microcontroller's frequency, clock frequency, and desired baud rate, you can, for the desired baud rate, you figure out what should be your baud rate generator register value for baud rate generator. Okay, so that's that. Let's do maybe. Of course, here there's an error, right? A little bit an error. So for that given baud rate, desired baud rate, your actual your actual UXBRG value should be 25.04166, but since we cannot have that value in the register, baud rate generator register, so we need to put like just 25 there. So that's the closest, right? So that's kind of a source of an error. Okay, so let's see how much error we get because of that. So if the actual baud rate, so this was the desired baud rate. Based on this desired baud rate, we calculate the UXBRG baud rate generator value, and we find 25.04 whatever. We ignore the decimal part because we cannot put that value into that register, so we just pick the integer part, which is 25. So that's a source of error. So let's figure out the actual baud rate. So we wanted the 9600, but actual baud rate is if this is 25, then if this is 25, then actual baud rate is gonna be what? So we can do that very easy. Baud rate is equal to, again, FCY over 16 UXBRG plus 1. Yeah, so if you just plug in the values, 4 times 10 to the 6, this is the microcontroller clock frequency, 16 times 25, that's what we found, right? So 25 plus 1. So from here, the baud rate is 9600. I'm not sure exactly what's that value. Let me calculate again very quick. Sorry guys, calculator. Just a second. Calculator. So it's 4 million over 16 over 26. So it's a 9615.38, 462 and so forth. Yep. So yeah. So basically we wanted desired baud rate was 9600. So what we got is 9615. So there is an error here. So, and how much error we have? So then error between desired baud rate and actual baud rate. Okay, so how can we calculate that? Like, So the error is equal to, this is like a standard error calculation method. Calculated baud rate minus desired baud rate over desired baud rate. Okay, so if we do this, we get 0.160256%. So it's approximately 0.16%. So that's the error we got. Is this significant? Not really, because because this is too small to cause any problem, right? So this is not like like if you have high or low. We can have issues if we have a slower or a faster baud rate than we desired, but like this is too small, because this is not like the thing. The good thing is this error, if it accumulates like for a long time, like if you keep having like in every data transmit, if you keep having this error and it accumulates for a long period of time, so it's going to be, of course, it's going to be a major problem and it's going to cause trouble. But the good thing is every time you like basically in UART, so you transmit, let's say one set of data bit, like a 8-bit, okay, and then the clock resets, and then you transmit another one, and you transmit another one. So then error is gonna kind of do not accumulate. So every time you do, the things reset it. So then you have a every time you have 0.16% error. So you are not gonna have it's not gonna accumulate. So it's not gonna increase. So and this much error is not gonna cause like a like skipping the like 1 bit due to high sampling, or low sampling, or sampling same bit twice because of high sampling rate. So it's not that significant if you think about it. This is not really a big error. Okay, so we are good there. So this is not as significant. I mean, if you have 10%, 20% error, that might cause problem, but this is very small. Okay, so that's it. So let's move on.